Hi everybody, welcome back to Cloud Space with Siba. My name is Siba and I will be talking us through the architecture for ECS. ECS is also known as Elastic Container Service, which is a service offering by AWS. We'll be talking about what it is and how it works and essentially how it then can benefit us as people who want to run a microservice architecture on the cloud. If you look at software development now in the modern era, there is a huge move toward running applications using the microservice architecture on one hand, but also running those applications as containerized applications, right? So if I can give us an example here or a depiction, you yourself might be in a situation where, so if you look at this diagram here, we are living now in a world where we have these applications that are microservices, and at the heart of this microservice architecture is these Docker images, right? So you'll have your application where you'll have one microservice that does one thing and another service that does something else, and collectively these services give us what we know as a microservice architecture, right? A microservice architecture, right? And that's perfectly fine. But if you've worked with Docker before, you'll realize that with Docker, there comes a responsibility to do a couple of things or to think about a couple of things, right? On the one hand, right, you have to think about one, pulling your Docker images, right, from whatever repository that you might be keeping. It could be Docker Hub, it could be something else that's offered privately. Then once you have pulled your images, then you have to think about starting your images, right? This is now you running your application. Should anything happen to the application, another thing you need to start then thinking about is how do we restart our application, right? If we don't need to restart our application, it's running and it's servicing requests. As that load of requests increases, then we need to start thinking about how do we scale it to meet that demand, right? And as we're scaling it, right, we need to think about how we can have our application highly available, right? Meaning that as we're scaling out or as services crash or stop, how do we keep the application resilient enough to serve requests, which is high availability, right? Now these are things that if you're running Docker yourself in a hosted environment, self-hosted environment, then these are the things that you kind of need not only to think about, but also these are very manual in and of themselves, right? So when we then want to run our containerized application or microservice architecture on the cloud, there are various options, right? If you're going to do it in the cloud, which is obviously more elastic and a more favorable choice in terms of meeting some of these requirements here, then you could run all of this in EC2, right? And this is in the context of AWS, right? You could run this in EC2, right? Which is, again, you're running it on the cloud, which you'll have the benefits to the cloud, right? But also, we still need to think about a couple of things if we're going to run this in EC2, which is, one, we have to think about the fact that now that we're running it on EC2 instances, we have to manage the instances, right? Number two, we have to do patches on it or on them, right? We have to think about how we would handle auto-scaling using auto-scaling groups, right? But on top of that, we have to still think about the fact that these steps over here would also still apply. So on our instances, we'd still need to pull the Docker images, but in addition to that, we'll still have to get the Docker runtime installed on there and then be able to do all of these things. Now, if you look at this whole process, this is a very manual process, right? And it's time consuming and it's very administrative, right? And so we need a platform that can do all of this for us on our behalf, so that our attention goes into running the application, making sure that we're deploying features at a very fast rate, and that we're meeting, and that we really are staying competitive. If you look at all of these here, none of them are adding any business value, right? Even though they are helping our application run, that's not where our application really should be. That's not where our efforts really should be focused on. What if we could offload all of this here to a platform that then handles it automatically so that we stay focused on this, right? And essentially this is where ECS comes in, right? ECS itself is an orchestration service for running, let's just say containerized applications, right? I'm going to add this, that is production ready, because I think this is key, right? So ECS, Elastic Container Service, is AWS's offering for, or platform for running containerized applications. Now, notice I use the word orchestration, right? And what I mean by orchestration is that ECS automatically handles this process, right? We give it configuration, we give it a blueprint, which we'll talk about a little bit later. We give it a blueprint that it then uses to do all of these steps on our behalf, right? And so this right here is essentially what we call orchestration. I'm just going to copy this here and put it here, right? This is what orchestration is. And so it's better than running it on EC2, because then all of this as well moves into the platform in terms of how it's handled, right? Now, another thing about ECS is that, yes, it's on one hand, it's an orchestration platform, but it's also managed, which means that it, like I've stated, handles all of the really unsexy, I'm just going to say unsexy, slash tedious administrative tasks. And I've mentioned examples of that, right? But because it's running on AWS already, there's a couple of advantages as well, because it means that we can also integrate it with a ton of AWS services. So think of, for example, sorry, IAM. We can use IAM for managing access. We can use ECR, which is Elastic Container Registry, for keeping our Docker images privately. It's a private repository, right? We could use CloudWatch, and this is obviously for logging and monitoring purposes. We could use load balancers for routing traffic. We could use so if we're looking for storage, for example, right, we could use S3. We could use EFS. We could use RDS for databases. Caching. We could use Elastic Cache, right? Elastic Cache, which is very powerful, right? Because it then means we have this platform that handles all of the manual work for us, but at the same time gives us then the ability to to integrate with all of these other services, right? So the question becomes, how does ECS work? Meaning architecture, right? Okay. In other words, how do these what components does it have, and how do those components work, right? There's really 4 components that I want you to think about, right? There's the cluster itself. I'll just say ECS cluster, all right? So there's the cluster itself, yeah? And then there's a compute layer. There's a compute and a network layer, right? Then there's the concept of task definitions, and we'll talk about what that is. There's the concept of tasks, and then there's the concept of services, right? Of a service, right? So in terms of the cluster, when we speak about the cluster, we are talking about really this is the logical, let me just use that one rather. So a cluster is really the logical grouping of all components, right? I'm just going to say required components to run our application. Okay, and I'll explain what I mean by that. Right. Let's just move this down a little bit. So a cluster is a logical grouping of all required components to run our application, right? And then in order to run our application within the cluster, then we need another, right? We need compute, right? So in terms of compute, we have two options to run. We have Fargate, which is a serverless option, and I'll talk about what that is. And then there's EC2, okay, which is I guess I'll say self-managed, if that's even a thing, right? All right, so there's our cluster. Essentially, when we create or when we provision a cluster, we need a network component, and that would obviously be the VPC itself. These are not core components to ECS, but I'm just putting these in there so that we understand that they are part of the process, right? When our cluster is provisioned, it's provisioned as part of a VPC for the networking aspect of things. And then in terms of compute, where the containers will actually run, we have two options: Fargate, which is a serverless offering, meaning that we're running our containers on virtual machines that we don't really have to manage. We don't have to do any of these tasks over here. That's what Fargate does for us. It'll pick up on the resources that are required, and it'll provision instances accordingly, and will handle all of the managing of those instances, right? The other option we have is to use EC2. But it also just that means that we then take upon ourselves those administrative tasks to manage these instances, and then to also think about how we scale them using auto scaling groups. These are not, like I said, core to ECS, but they are very much part of the process as well. Now, what then is core to ECS is task definitions, tasks and services, right? We want to think of task definitions really as the blueprint for the containerized application. Okay, this is the blueprint. In other words, a task definition is a definition file where we say this is the container, this is the image that's going to be used to run a container. These are the resources it needs. These are the volumes it needs. These are the environment variables that, for example, that will need to be passed on to the application, right? Now, all of the configuration in the task definition file is then used to run a task. And we need to think of a task really as a running instance of a container, right? Running instance of a container, right? That's all it is. It's a running container, right? And as it's running on the platform, ECS, then what ECS does automatically, again, back to the orchestration concept, ECS takes this definition file, it looks at all of this, right? It looks at all the configuration here and does all of this on our behalf. It'll pull the Docker image wherever it is. It'll start the container. And now, importantly, it'll start the container, but should the container crash, it won't restart it. Should the load increase, it won't scale it. All right. And I'll show you why that's important. The reason that's important is because of the next component of ECS, which is a service. Now, a service does a couple of things, right? If we use a service, then a service becomes responsible for launching, monitoring, and importantly, restarting tasks, right? So ECS is a component of a service, and it's responsible for launching, monitoring, and restarting, right? Meaning that a service helps us do these three components here, which is restarting, scaling, and making sure that our application is highly available, right? I hope that makes sense. So now I just want to depict what what the architecture might look like for running application. So in the context of running application, we could have our tasks here, and essentially our tasks. So write tasks there. Just do this. Not tasks, tasks. Tasks. In fact, let's just make it singular. Then I'll delete these two here, and then just copy these over here. Okay, cool. So within our cluster, okay, now I'm not going into details in terms of how the networking would be set up in terms of subnets and all of that, because I don't think that's relevant. Okay, there we go. So we would have our tasks, and before our tasks, in front of our task, we would have our service. And what will happen is, our service will be launching these tasks here, right, as well as monitoring them, right? So should any of these tasks, for example, crash, our service will be responsible for making sure that it's restarted again, right? And that keeps our application highly available as a result, right? But another important thing about a service is that a service can also help ensuring that our application is accessible, right, from the internet, right? So basically, like I said before, because we can integrate ECS with many various services of AWS, we could actually have a load balancer that then sends traffic to our service, and our service will actually act like a load balancer itself in terms of routing traffic to our different tasks or different running instances of our application. So it's a very powerful concept, and all of this then enables us to then run our application really quite easy. Remember, I also said that it's production ready, meaning that there's little that we have to do, even if we're running a production application on ECS, right? So that's just to summarize, right? So ECS is an orchestration service, which means that it handles the launching, the provisioning, and the restarting of a containerized application, right? It has four components, core components. There's a cluster component, there's a task definition component, tasks component, and a service component. We spoke about how ECS itself, the ECS cluster, is really a logical grouping of all the components to run our application. We spoke about how tasks really are the blueprint of how our containers application will run, how a task is a running instance of that application, and how a service really manages the launching, the monitoring, and the restarting of our service. And then we mentioned how all of that then will run on a compute layer, either on Fargate, which is really the most preferable way to do it, or on ECS if we really need to self-manage our application. So this video has been on the architecture of ECS. I hope you found value in this, and if you do, please like and share and subscribe to the channel. Also, I will be doing a video where I take you through how we provision an ECS cluster, and then later on, in addition to that video, I'll be showing how we can run a Node.js application on ECS. Thank you so much for watching. I really appreciate your time. And again, thank you so much for being here and sticking around. I look forward to seeing you in the next video. Thank you so much for watching.